Hello everybody, first and foremost a very happy new year. So it's now the time that we chase our same dreams with new enthusiasm. Okay, coming to today's lecture, we are going to discuss the screw gauge. Okay, it's a easy topic as compared to your vernier caliper, and if you have already learned vernier caliper, it will be even more easy. Okay, so let's directly go for the major parts. So today is the last lecture of errors in measurement, and after that we will begin with motion in a straight line. Okay, so major parts, first one is a main scale, or it is also called linear scale because it is in a straight line. Main scale, linear scale, and a pitch scale. We'll come to this why it is called a pitch scale. Okay, second major part is a circular scale, so you can use the short form ms for it, and this is circular scale, CS. Okay, so main scale is basically hidden. uh, First it is hidden, so when you go on opening it, so when you go on rotating this 1 divisions, this the main scale is behind it. So once you go on opening it, 1 divisions will be revealed. So main scale is behind this cylindrical portion. So once you go on opening it, 1 divisions, I know you cannot see now, but I'll put a picture up there. So 1 divisions are revealed. Okay, so main scale is behind, and it is when it is closed, when your instrument is closed, it is hidden. Now what is this circular scale? Circular scale, as you can see here, over here, it is spread over the entire circumference of this cylindrical ring or cylindrical portion. So it begins with a 0, and then it has certain number of equally spaced divisions. Okay, so the main point is it is spread over the entire circumference, and hence it is called a circular scale since it is circular. Okay, it has certain divisions which are equally spaced. In this case there are, so this is 45, 46, 47, 48, 49, and again when you come to 0 you count the next division, say it's 50. Okay, so 45, 46, 47, 48, 49, 50. In this case there are 50 divisions. It can be anything depending upon your screw gauge. So this is the circular scale, and the linear scale is hidden. So once you go on opening it, 1 divisions are revealed. Okay, so now coming to some other parts, some others, so which are not that important. One among them is a reference line, stud, screw. Also there are thimble and other parts. It's not over here. Okay, so reference line, stud, and screw. Okay, so what are these? So stud, I'll go to stud first. So stud is this metallic portion which is to the left hand side, the small, so which is not movable, it is fixed. Okay, this small metallic portion is a stud. Screw is this portion. Okay, now in this model it is flat. Some might have it in the form of screw. Okay, put a picture there. Yes, it has in the form of screw, right? Okay, so those, so that's why it is called screw, and it is movable. So once you go on opening it, it moves farther away, so you can stuff in things there, and here will be the measurement. Okay, now reference line is this line. Okay, so the your linear scale, the main scale is on this line. Okay, it will be helpful in determining zero errors and all, so it is one of the important parts, I'll say. So that is the reference line. So over that and reference line, this goes on, and over that reference line the entire scale is over there, so entire main scale. So this is the reference line. You have a 0, then you have 1, 2, suppose millimeters for now, and so on. Okay, so these are other important parts you can quickly note those down. Okay, now let's go to the principle. How does it works? So now let us go for the principles. So before that, I need to define a term which is pitch. So we are learning how our micrometer or screw gauge works. Micrometer is a special case of the screw gauge. Okay, so pitch, it is the distance traveled by screw in one complete rotation. Okay, or I miss a important word here. It is the linear distance. So this is a very important word, linear distance. So it is the linear distance traveled in one complete rotation. So what do I mean by this? Suppose if I rotate it, go on rotating it, it also moves a distance this way. This screw is moving outward, and even this cylindrical portion is moving outward, and it is showing some main scale reading. Okay. So, but what is the pitch? Pitch is linear distance in one complete rotation. So let me close it first. So I have, yeah, so I have this condition now. Now I give it one complete rotation. So I begin at 0, I go on and on till 0 comes back. Okay, so I come back to 0 again. So this is one complete rotation. So what is the linear distance traveled? So it did shift a bit there, right? You just imagine that you have nuts and bolt, you have it completely closed. So once you give it one complete rotation, so you give it one complete rotation, it will move certain distance outward, right? They are closed for now. You take nut and bolt, put it fix it, and then you slightly give it one complete rotation. It will also move certain distance outward. Okay, so that is linear distance, outward distance, not the circumference, the outer distance, linear distance that it travels in one complete rotation is called the pitch. Okay, very simple, right? So what can be another definition of pitch? You take the same case of nut and bolt. Okay, now you have those closed. So when you give it one complete rotation, no, you can try it. Two threads will be shown. When you give it one complete rotation, you will see two threads. So what is the distance? So can I say it this way, that pitch is the distance between two threads on screw. Can I say it this way? You can try it. So you take a nut and bolt and completely fix it, and then give it a one complete rotation. You will see that only two threads are shown. So you give it one complete rotation, the distance traveled was the distance between the two threads. So we can say that pitch is the distance between two threads on screw. Now this one is a flat one. So hang the picture up there, please. Yeah. Yes. So this one is a flat one. There you can see it is certain sort of a screw type. So there the distance between two what can I say, two threads on that screw will be the pitch. So they might want you to confuse in a question. They'll state pitch this way. So they'll say the distance between two consecutive, rather. So don't just consecutive. Okay, remember this. It's the distance between, I'm missing important words, I don't know why. 2021. Okay, so distance between two consecutive, it's obvious, right? It's logic. So distance between two consecutive threads will give the pitch. Okay, so in one question they might frame it this way. So not to confuse, they are just stating pitch. And one more feature of pitch is that pitch is graduated, it's marked rather. Okay, so graduated means marked. You mark 1 0 2, like 0 1 2 3, this way it is marked on main scale. So what does this mean? This is a very beautiful point, very beautiful point. Okay, so pitch is graduated on main scale. So you give it, let's try giving it one complete rotation. So once you give it one complete rotation, it has traveled some distance linearly, that is the pitch. But pitch is graduated on main scale, means that when you give it one complete rotation, one division on main scale will be shown, right? So you give it another rotation now, another 0 to 0. Now two divisions are shown. You give it another one, and then three divisions are shown, and so on, right? So each of the division on your main scale is one pitch for one division. Second two pitch, two times the pitch if it's the second division, first division, the zeroth division. So once you rotate it one complete rotation, this division will be shown. Your circular scale will come here. When you give it two complete rotation, your circular scale will be here, like on it, exactly on it, but it will be slightly shown. Okay, so each of the divisions on your main scale will be will so rather pitch is graduated on main scale. So each of the divisions represent pitch. So first division, suppose they in a question they'll say three divisions on the main scale are shown. So what is the reading? So three times the pitch. Okay, four divisions are shown, four times the pitch, and they'll provide you the pitch in that case. Okay, so this is also a very important point. Pitch is graduated on main scale. Quickly note it down, then we'll go for the least count. Let us now go for the least count, but just note down that one rotation gives us the pitch. So this will help us for our least count. Now, what is the least that you can think it will measure? Now, is this the division? Let's do one thing, that we rotate it in such a way that the first division on the circular scale comes in line with the reference line. Okay, we rotate it only that much that the first division on the circular scale, the circular one, the first division 0 1, the first division comes in line with the reference line. So what is the amount of rotation in that case? For this case, what is one rotation? One rotation is, okay, for one rotation, how many divisions do you think it will require? You can easily make that out. Now this is 0, so it has to again come back to 0. So either you can count those all, or either you can do is count it backwards. So 45, it will obviously cross 46, 47, 48, 49, 50. So it, for complete rotation you require 50 divisions. 49, then this will coincide. Okay, the second last division, but you want the 0 to come back to the same position. So 49 and then 50, 49 and then 50. Okay, so for one rotation in this case we require 50 divisions. But what we did was we just rotated one division, right? In our case, now we want to measure the least count, so we know that it will count the least when the first division here coincides with the reference line. So what was the rotation in that case? So for one division, what was the rotation? So safely we can say that for one division the rotation is 1 by 50, right? This is x. So wait, so x 1 by 50, so x is, so 1 by 50th of a rotation, since we have 50 divisions over here. Okay, so now we can use that logic over here. So 1 by 50th of rotation will give us the least count. So can you derive something for least count from here? So least count will be pitch divided by pitch upon 50. So is it a general case? No, because we had chosen 50 divisions on the circular scale. Now it can be 100 as well, this can be 100 as well. So what will happen in that case? So this will be 95, 95, 96, 97, 98, 99, 100. Okay, so what is one division in that case? How much amount of rotation? It will be 1 by, so x will be 1 by 100. So 1 by 100 of a rotation. Here also it will modify. So 1 by 100 of a rotation, and this will give us pitch upon 100. Now if we want to generalize things, okay, so let's take directly, there are n number of divisions uh, on the circular scale. So it will take n number of divisions for a complete rotation. I'll take capital N. So it takes n number of divisions for complete rotation. So for one division, what is the rotation? So for one division, the rotation is x is 1 by n. So 1 by n. So 1 by n. Come back over here. So 1 by nth of a rotation. One rotation gives pitch. 1 by nth will give us the least count, the least that it can measure. So now what is the least count? Pitch by n. That is just the idea. All you have to remember is the least count. Okay, least count is pitch by n. What is n? N is number of divisions on circular scale. And I hope you have remembered what pitch is. Pitch is the linear distance that it has traveled in one complete rotation. Linear distance in one complete rotation. One rotation is pitch. The linear distance in one rotation. And least count is also a linear distance. It is not this distance. I'll come to it. Don't keep misconceptions in your head. Okay, so this is the least count. Now, what will be the measurement? Measurement or the final reading. First of all, when we stuff in things here, okay, I'll put something over here. I'll put a pencil. First of all, the first thing that we can note is the main scale reading. Yes, it's directly visible. The scale shows a certain number of divisions. So you count those divisions, and how you measure the main scale reading? How do you do that? So number of divisions, so main scale reading. I'll write it over here. It is not important that much. So I have told you that pitch is graduated on main scale. So whatever number of divisions that you see on the main scale, so number of divisions that are visible when you stuff that thing, so that number of divisions into pitch. So pitch will be certain distance, 1 millimeter, 2 millimeter, 3 millimeter. So whatever the number of divisions that are visible to you on the main scale, once you stuff that something, the thing that you are going to measure into your pitch, okay, the number of divisions that are visible to you, you can directly write it as MSR, so main scale reading. It will be mostly provided in this cases, but sometimes you need to use this. Not more useful, but sometimes you need to use that logic. So they'll say that the third division is visible, so all you have to do is 3 into pitch, because pitch is graduated on the main scale. Okay, MSR, does the circular scale count as well? Yes, it was the one who gave us the least count due to, yeah, it rotated that much, the linear distance. Yes, it also count. It was responsible for the least count. So we know that one division on the circular scale corresponds to least count. I didn't say, mind you, one division equal to least count on circular scale equal to least count. I didn't say this. This is not wrong. This is completely wrong. Sorry. So this is completely wrong. I said this corresponds to, it is proportional to. Okay. Why is it not true? Because least count is linear distance. So when you give it one, like the one on the circular scale comes in line with the reference line, so it coincides with the reference line, then the linear distance traveled, it is not this distance, it is not that distance, it is the linear distance traveled. So least count is also the linear distance traveled, it is not this distance. So it is wrong to say this. 1 division on circular scale equal to least count is wrong. 1 division corresponds to least count, okay, on circular scale I write. Okay, so I need some space. What I'll do is I'll put circular scale on top. So I'm referring to circular scale every time I'm writing this. So 1 division corresponds to least count, because when you give it 1 division rotation, the linear distance that will be traveled will be the least count, okay, not this distance. So this is wrong. So I won't write it, because those writing the notes will be confused. Okay, copying the notes from the website will be confused. Now what can you say about 2 divisions? Simple, 2 into least count, because 1 division is least count, 2 divisions will be 2 into least count, because they are equally spaced. Each of them, this distance is equal to this, equal to this, equal to this. They are equally spaced, right? 3 divisions, 3 into least count. So what if the nth division is coinciding? So I'll write the measurement later. So in general, if the nth division is coinciding, if the first division is coinciding, you just have to write the least count. Second division is coinciding, you say twice the least count. Third division, thrice the least count. Nth division, so n times the least count. So this n is coinciding division, okay? So let us write the final formula down. I'll write it over here. So measurement is equal to MSR, main scale reading, plus circular scale reading. So measurement equals main scale reading. If you want to replace it, you can, but I suppose that you should remember this at the back of your head. Okay, it is based on the idea that pitch is graduated on the main scale, and circular scale you have to write this, because in most of the cases they won't provide you the. So this is the absolutely correct formula for measurement if there is no zero error. Now zero error, those who have seen vernier caliper would have directly known it. It's a little bit different in case of screw gauge. Okay, so I hope you got the idea of least count. So 1/n of a rotation, the linear distance and not the distance between the circular scale. Okay, circular scale division. So it is the linear distance. When you give 1 out of the total number, 1 out of nth rotation, what is the linear distance traveled? So that will be the least count. So we found it to be pitch by n, and now we went for measurement, which was main scale reading plus circular scale reading. So main scale reading we directly know, okay, by that idea. I won't speak of it again and again, I'm just revising now. Okay, this n is number of divisions, total number of divisions on circular scale. Now this is for circular scale, this for this idea that circular scale reads as well, it gives us a reading as well. So for 1 division, it gives us the linear distance was least count. 2 divisions, what will be the linear distance? 2 into least count, since they are equally spaced. Nth division, for nth coinciding division, it will be, sorry, excuse me, n into least count. So n is coinciding division of circular scale. No doubts here. In vernier caliper it was a bit doubtful. Here there are no doubts. Okay. Now let's go for zero error. You can quickly note this down. Those who have seen vernier caliper will know what is zero error. YouTube, can you suggest that? Yes, you can watch that as well now. Later, once we finish this. Okay, so let's finally go for the zero error. zero error. So I won't define it, but it is one of the instrumental errors that we have. What happens in that case? So we'll make 3 columns. First one is no zero error. Here we'll have positive zero error, and here we have negative zero error. Positive measures more, negative measures less. So if your instrument is measuring less than what it is supposed to, then it is a negative. If it's measuring more, then it is positive. Okay, we'll come to know. So we start with no zero error. So no zero error we have already discussed. So 0, 1, 2, 3, 4, 5, and you can have anything over here, n minus 5. So n minus 5, n minus 4, n minus 3, n minus 2, n minus 1, n. I hope you are not confusing. You're not confused. So I'll take 95. So 96, 97, 98, 99, 100. Okay. I had taken the general case. So here nothing changes. The measurement formula remains the same, which was measurement was main scale reading plus n times the least count. So here no changes. What about positive zero error? Okay, so positive zero error, in that case what will happen is you take 5 over here, 0, and you have 10 over here. So what happened is that it, if you can relate it, it has already moved certain distance. The 0 is down, so it has already moved certain linear distance. So your instrument is actually closed, it's not measuring anything, but your 0 of the circular scale is not matching or not coinciding with the 0 of your reference line. Then it is measuring something before even we have started, right? So we have closed the instrument, but we find that the 0 is below the reference line. The 0 is below the reference line. So you can relate that it is measuring something extra. And before we have started, it is measuring something extra, right? It is measuring something extra. It is already rotated, right? So what it is measuring extra? So what is the coinciding division? 1, 2, 3, 4, 5, 5, right? Okay. So how can you state that? So if you say it, it's basically circular scale reading. Okay, basically circular scale reading. So how do you say that? N into least count, right? So zero error is also a circular scale reading, coinciding division into least count. Just in case the n here is the coinciding division before measuring. So we have not started measuring, we have closed our instrument, and yet 0, this both zeros are not matching. It's an instrumental error, right? So coinciding division not measuring. So while not measuring, so we have closed our instrument, but still we find that 0, both the zeros do not match. The reference line, the 0 of the circular scale does not match with the reference line. So in that case, it is a positive 0 error. Now let's go for the negative 0 error, and here is the difference. So don't just wrote the formulas. You'll come to know now why not to. So suppose we have 95 over here, 1, 2, 3, 4, 5. So 95 and 0, it was 100. 1, 2, 3, 4, and here we'll have 90. So here it's measuring something less, right? In this case, one more point, the 0 will be visible. The 0, it will be on the 0, right? Almost it would have, okay, sorry, the 0 is visible in this case. I have exaggerated it. I have shifted it a long distance. Rather, this will be very close to this, okay? And in this case, the 0 won't be visible. Why is it so? Can you think of it? The 0 will go into it. Okay, I'm drawing it perfect now. Why? Why? Okay, so why is the 0 hidden? You can relate that because it has rotated oppositely. Here if you go to see, it was rotating anti-clockwise and it was coming outwards anti-clockwise. okay. But in this case, what has happened, it has rotated clockwise. So 95 was, see, come here, 95 was below and it has rotated this way. It has rotated this way. So it has covered a distance this way. The linear distance is not in this way, it is this way, right, towards the left. So it is counting something negative. So that is the reason it is a negative error. Here I'll put a positive sign, okay. So 95 was over here, it just rotated in the opposite sense. Usually it used to rotate this way, but now when we closed the instrument, it so happened that it rotated so much that the zero was hidden. Zero came inside it, okay. It rotated this way and it traveled certain linear distance, and through which the zero was closed. So another way of saying the negative zero error in the question is zero is hidden. So they'll say zero on main scale is hidden. So instead of providing saying that it has, your instrument has a negative error, in question they'll say the zero is hidden. So you have to uh, it has to strike you that it is negative zero error, right? So it is another way of framing good questions, okay. So you got the idea. 95, it rotated in the opposite sense. But now is it still that zero error is n into least count, and n is the coinciding division? I mean, so here it's 95 into least count. Is it that thing? Don't just wrote the formulas. That's why you should not wrote minus sign of course. Is it the same formula? No, because now it has rotated opposite. And if you see, it has just moved 5 divisions, 1 2 3 4 5, right? It has just moved. It was 0 first, it came in this position, and we found that the claws were not closed, so we rotated it even more. But how many divisions does it has traveled? So 1 2 3 4 5, yes, 1 2 3 4 5. It has just moved 5 divisions, and you cannot say it has moved 95 divisions, because it has moved opposite, in the opposite way. So this is not the correct formula. The correct one is actually n into LC, you can say, and where you can redefine n as the divisions shifted, or the very good formula they have found is n minus n into LC. So instead of looking for how many divisions has shifted, you can by heart this formula, where n, capital N, what was capital N? Number, total number of divisions, right? Total number of divisions on circular scale. So total number of divisions, here there are 100. 95, 96, 97, 98, 99, 100. So here you can see that 95, 96, 97, 98, 99, 100. And so 100 minus, I am finding the zero error of this, it will be negative, of course. So minus, you can say, yeah, so minus the coinciding division 95 here, and n, small n, is coinciding division. So either you can check for the division shifted, and then you can redefine that small n. You can use the same formula and redefine this n as division shifted, or you can directly use this formula to be safe and it's not confusing. So coinciding division of circular scale. Okay, so here the least count we don't know, so we'll 5 into least count, and of course a minus sign, right? So this is the error, negative error. Okay, so what will be the change in the formula, the measurement formula in these two cases? Here it's the same. So those who have learned vernier caliper can directly guess it. It will be MSR plus N into LC minus zero error. Okay, zero error is always subtracted. That is what I had told you in the last lecture of 2020 or vernier caliper. Okay, So zero error is always subtracted because in positive it is measuring something extra, right? It is measuring something extra, so you have to subtract it. In negative we have negative sign, so in that case it is measuring negative, but this negative sign and this negative sign, uh, negative into negative positive, and finally the zero error adds. Okay, finally. Okay, so in this case it is positive, so it's directly subtracted. In this case, if you go to see, when you plug in, it will be finally added. So in case of negative it will be added, so it balances the stuff. Okay, one more point which I missed while discussing vernier caliper was zero correction. Zero correction, so it's one of another terms. It means it means negative of zero error. So zero correction is minus of zero error. So you can, if you have to define new formula, you can use this now: MSR plus N into LC plus zero correction, because minus ZE is zero correction plus zero correction. So this is just a point, not that much important. I hope you got everything that I discussed over here. This is the new thing over here, which was not there in vernier caliper. Okay. This N is the coinciding division when we are measuring, and this one is when the instrument is closed. It is due to error. Okay. Quickly note this down. Now it's time for lots and lots of problems. Only 3. Okay. Not much to trouble you on 1st of January. So let me write down the problems. Numericals, I'll say. Let's not speak of problems in 2021. Okay. So when So here is a question on the board. It says when circular scale is given 5 rotations, you have done 5 rotations. The linear distance traveled is 2.5 millimeters. Okay, 5 rotations. But for pitch we want 1, so that is the point. So 2.5 millimeters on main scale. So it has given you certain info. The total circular scale division, total number of circular scale divisions are 50. There is no zero error in that instrument. So when now you are measuring stuff, so you put a metal strip between the screw and the stud. Okay, the main scale reading when you are measuring is 4 millimeter. They have directly provided you. Okay, and coinciding division is 41. So coinciding division of the circular scale is also provided. Find thickness. Straightforward question, very easy. You can write. Okay, 1, 2, 3. Now I will do it. So correct answer is 4.41. Give it a honest try. Okay. Now, first thing what we need to do for measurement, we need is main scale reading. Main scale reading plus n into least count. Now I think it's very easy. Yeah, it is very easy because they have already provided the main scale reading 4 plus n, coinciding division is 41, into least count is, now for least count what do you have to do? Least count is pitch upon n. So you know what is n, which is 50. I guess so, yes. It is 50. Total number of circular scale divisions 50. What is pitch? What is pitch? They have not provided anything information about that, but they have given this very first line says that 5 rotations gives us a reading of 2.5 millimeters. On the linear reading is 2.5. So for 5 rotations it is 2.5 millimeters. But what is pitch? Pitch is for one rotation. So pitch or one rotation is how much? Very simple, straightforward question. So x is equal to is what do we want? This won't be pitch. Pitch is the linear distance. Here it is pitch. X is pitch. Okay. So x is 2.5 millimeters divided by 5. So it gives us 0.5 millimeters. It was millimeters here. So you find what is x, which was the pitch. So now it's easy. So you put pitch is now is 0.5. Cancel it, 0.01. Okay, I cancelled it. Basic maths. Now list count. It was in millimeters. Here also you put the same value, and then you'll have 4 plus, shift to decimals 1 2, 4 plus 0.14, so 4.41, 0.41. Yes, so A is the correct option. So it was very easy. First we did this, we got stuck at the least count, so we had to go for the least count. Least count was pitch by n, so they had provided it the pitch in some fancy way. So we calculated the pitch, then we substituted and got the least count. Finally substituted the least count and got the answer. Very simple, very easy question. Let's go for question 2 now. Da-da-da-da. Where is that? So they have provided directly the figure. So before measuring, sounds like zero error. So the second question is over here. They've asked for thickness of plate, and you have your options over here: A, B. Can write it somewhere else. Here only I'll write A is 3.84 millimeters, B is 4.16 millimeters, C is 4.48 millimeters. So these are very good options. If you do it, you'll come to know. Okay, quickly try it, give it a honest try. Okay, so now I will do it 1 2 3. I will not disclose the answer. Try it. Okay, so here before measuring, the pitch is 1 millimeter. Pitch will remain same even after measuring. This will also remain same. But here it is what? So before measuring, we have closed the instrument, but we find that the 30-second division is matching. Actually the 0 should have been matching, but now the 30-second division is matching. So here is, so they want to say that there is a 0 error. Okay, so there is a 0 error. Now what can we do? This 0 error, is it positive or negative? Is it positive or negative? That is the greatest question the nation wants to know. Yes. Zero error is positive in this case. Why? And how can I say that? Because this 0 is not hidden. If it was hidden, it is negative. If it is not hidden, it is positive. Okay, so 0 error is positive. And for positive one, we have a easy formula, which is plus n into LC. Coinciding division is 32. Least count, we don't know, but we can calculate that. So it is pitch by, so pitch by n, easy peasy. Pitch is 1 millimeter divided by 100. So that gives us 0.01 millimeter. Here also 0.01. So shift to decimals. So this is the zero error. Zero error is over here. So finally that is the case after the measurement. We have put in a plate and that is the case. So measurement equals, I'll put x equals because that is our measurement. Okay, so first we have to add the mean scale reading plus circular scale reading, which is n into LC, n into LC minus 0 error. Okay, this is the formula. Now, what is the mean scale reading? So count the number. Now you have to use that logic. Mean scale reading is equal to n times the pitch. What is this n? Number of divisions shown. So 1, 2, 3, 4. So 4 times the pitch. Pitch is 1 millimeter. So 4 millimeters it will be. So it means to say it is 4 millimeters. Okay, so mean scale reading is 4 millimeters. Now let's go for the circular scale reading, which is coinciding division while measuring this 16 over here. They have shown that into least count 0.01. Now minus the 0 error finally 0.32. Okay, so this will give us 4 plus 0.16 minus 0.32. 4 minus it will give, because 32 and 16, 32 is double, so I'm doing maths now. And as usual, I don't provide any logic for maths. Calculation is calculation. So yes, you can say it as 3.84. Yes, 100 minus 16 will be 84. Yes, 4, 3. Yeah, 100, right? Okay, 3.84. You can calculate that. It is now all over in millimeters. So the answer is in millimeters as well. Very easy. The only problem was to sort which sort of error it was. Was it a positive or a negative? Since the 0 is not hidden, it is positive 0 error. Nice. Okay, quickly note it down. You should try actually then noting down problems. Question number 3. I hope the recording is going on. Yes. Sometimes I forgot to record and record the whole lecture. Things happen. 0.5 millimeter. So here is the question. I'll quickly give you the options. 1.1 millimeter, B is 1.2 millimeters, C is 1.3 millimeters, and D is 1.5 millimeters. C is 1.4. Okay, so try it. It has something different to say, but not that difficult. Okay, I'll release one more homework question on the website along with the notes. Okay, so this is the last question for the day. Quickly try it. 1, 2, 3. Okay, I won't disclose the answer. Okay, so what does this question has to say? It has told us that pitch is so and so, half a millimeter. Number of circular scale divisions 50. When screw and stud touch, what does this mean? This means that we are not measuring, and 20th division is coinciding. Oh, zero error. It means there is some zero error. So this line tells us that there is zero error. So 20th division of circular scale coincides with the reference line, and 0 of the linear scale is hidden. Oh, 0 of the linear scale is hidden. What does this has to say? Is it positive or negative? So here it means negative 0 error. So you have to go on decoding the question. So 20th division, this is data, and it means negative 0 error, this line. Okay, when a plate is placed, why are we measuring only plates? So plate is placed, it reads 2 divisions on main scale, okay, and 20 divisions on circular scale. So 20 divisions, it's matching on the circular scale. The thickness is easy. So measurement equals okay, main scale reading plus circular scale reading minus 0 error. 0 error is always subtracted. So main scale reading, what is that? 2 divisions. 2 divisions, 1 division is pitch, 2 divisions is 2 times pitch. So what is pitch? 2 into 0 0.5. So 0 0.5 is half. So you can write that as 1. Okay, 1 millimeter. 2 into 0 0.5 is 1. Okay, math. N into LC. Now this is when we are measuring. So while measuring, what was the plate is placed, and then it is the 20th division on the circular scale. 20 into least count. So 20 into least count, which we don't know. Let's find out that least count is pitch, which is 0.5 upon number of circular scale division. It will be again 0.01 only. 0.01 millimeters. This was in millimeters, yes. So 20 into 0.01 minus 0 error is always subtracted. So now take care that it is negative 0 error, right? It is negative 0 error. So the formula that you have to use is minus n into least count. Okay, you have to use this because we are counting for the division shifted, and if you do coinciding division directly, then you are getting something wrong because the screw gauge has moved in the opposite sense. Okay, you use the formula, you will get it correct. 50 minus, what is the touching coinciding division when it is closed and screw and stud touch? 20. So 20 into least count we already know is 0.01. So 50 minus 20 is 30 into 0.01. So that gives us minus 0.12 shifting, 0.3 millimeters. Okay, so 0.3 millimeters minus, so it is minus 0.2 shifted, no, 1 2, yes, 0.3 millimeters. So 1 plus, this will be 1 2, 0.2 minus plus 0.3, 0.2, 0.3, 0.5, 0.51, 1.5. So 1.5 millimeter, D is the correct option. So yeah, you can note this down. You found the least count and 0 error over here. It was a negative 0 error, so that is the only special thing. You won't find very tough questions in micrometer screw gauge. Okay, it's a comparatively easier topic. So that's all for the day, and let's do something YouTuber kind of thing. Please like the video and subscribe to my channel. We are just 9 subscribers away from that 100. And till then, keep enjoying physics.